Hello everyone, welcome to Clashing Coder. So in this video, we will see the question that is isomorphic strings. So this is a question that is typically asked in Amazon, Facebook, Google and other companies. So it is a basically easy level question based on strings as the name suggests. So first of all, let's see the problem statement, then I will explain you how we can solve this question. So let's see. So given two strings S and T, describe if they are isomorphic. So what is isomorphic? Let's see. So two strings S and T are isomorphic if the characters in S can be replaced to get T. So basically that means that we have to convert the string S into T. So let's see. All the occurrences of a character must be replaced with another character while preserving the order of the characters. So this seems to be difficult, but I will explain you using the example. So first of all, let's complete this problem statement. So no two characters may map to the same character, but a character may map to itself. So let's see from the example. So also let's see the constraints. So you can see the string length will vary from 1 to 5 into 10 to the power 4, and the length of the T and S is equal. So that means we are given that strings will be always of equal length, and S and T can consist of any valid ASCII characters. So there can be there can be special characters also, there can be capital or small lowercase characters also. So let's see the example, then you will you will get a clear idea of what the question is asking us to do. So let's see. So you can see this is the example that is given here also, the egg and add. So what is isomorphic now? So we have to return actually true or false if the string both the strings are isomorphic or not. So let's see how we can determine if it is isomorphic or not. So you can see this is egg, so I've written it here, and add over here. So what we have to do is we have to convert this S into T. So we have to convert the S string into T. So to do that, what we have to do is we have to replace a character in S with the character of T. So the character at that place, you can see this E is here, it is at 0th index, and we have to replace all the E's in S by the character A for this string. So if that means, you can see here it is given that all the characters of must be replaced with another character. So that means if egg is given here, okay, egg is given here, then for every E we will have to write A instead of E. For every E we will have to make it egg. So from egg we have to make it add. So to do that, what we have to do is we have one condition that we have to, if we change a character E, so if we replace E by A, so then we have to write A instead of E at every position, and the order should also remain same. So you can see if we replace this E by A, so okay, we have replaced it by A. So now nothing, so all the conditions are satisfied till this point. So now we have to convert this also, these two GG to D to make it T. So this S string into T. So let's see. So how we can replace G? So we can replace G by D. And as you know, if we replace G by D, so we have to replace all the occurrences of G in the string S by the character that we are replacing it with. So it is D. So we will write D instead of G. So we will write D. So you can see it becomes add. So this is what we have to do. Now what if our condition fails? So let's see this example. So you can see here we are given FO, and here we are given bar. So now when we try to convert this S string into T, so what we will do is we will replace this F with some character B. Okay, we will replace it with B, so it will become B here. Now we are left with O and O. So as we know that we have to replace this O with another character. So now we have formed, till this point we have formed B. Okay, instead of F we have B. So now we have to convert these O's into A and R. So now if you see carefully, as we know that a single character can be replaced by another character, but it cannot be mapped to two different characters. So that means here you can see O is mapped to two different characters. Here we cannot change, if we change O to A, okay, then we will have to replace the other O also with A, because all the occurrences of the same character will be replaced by the character that we are trying to add. So you can see here we added A instead of O. So for all O's in the string S, we will have to write A. But if we write A, you can see B, A and A, but it will not become bar, it will be different. So that means this is these are not isomorphic. Now if you see this example, that is, let's see. So one example was given. So let's see, we are given paper and we are given title. So this is the example actually, title. So now if you see in this example, if we replace this P, okay, this P with T, so here we will get T, and this A will remain as it is. So now we are not replacing it, and you can see this is P, so it will be also replaced by T. So that means we have successfully replaced these two characters, okay, these P's with T. So now when you come to A, so A we have to replace with I, and there is no character map to I, so we can simply do that. We will simply write it I, and there are no occurrences of A, so nothing will happen. So now when you replace E, so E will be replaced by L. So it is also possible because there is only one E and it will be simply replaced by L. So there will be no problem of like duplicate characters. So now if you see R, so R will be simply replaced by E. So sorry, this L and this is E actually. So let me write it like this. So this is L actually, and this is E. Sorry, this is L and this is E. So this is what, so this, that means these are isomorphic, so we will simply return true. So I hope you understood the problem statement actually. So let's see how we can solve this question. So one more thing I want to tell that. So if you see this question, so actually you will have to think like as I told you, we have to actually return answer in true and false. So that means we don't have to actually form the or convert the strings. So what we can do is we can simply create a map or two maps, or we can use a map and set. What we will do is for every character like this, so we will add or map the another character, the corresponding character in the T to E. So you can see A will be mapped to E. So that means that we know that in dictionary also actually the data structure we will use for this will be actually dictionary, or you can say hash map in C++, or it can be map or unordered map, and in Java it will be hash map. So hash table or whatever you can say. So it will be actually a key value pair. So here the key will be the character in S and the value will be the character in T. So now E is mapped to A. So now when you see, now we will check and we will also maintain a set actually. We will maintain a set. So this will be the dictionary. This is the dictionary. You can see key and value, and this will be our set. So now what we have to do is now we will check another character. So another next character will be G, and this is D. So we will map the G to E. So we will save it in our dictionary that we have encountered these characters and the G is mapped to D. So now what is the use of the set? So now to how do we know that this character that we are mapping it with is already used? So if we like have another instance, like if we have another character that is like if we have L here, so when we map L to D, you will check here L to D. So now you can see D is already used, so we cannot use a same character for two different characters. So that is why we have to get to know this. So we will save it into the dictionary. So when we are updating this dictionary, we will also add this character that we are mapping to the another character to the set. So we'll check if this character has already occurred. So that means it is mapped to two different characters. So the isomorphic term will fail. So we will simply return false at that point. So let's see how we can solve this question, and I will also explain you the algorithm clearly now. So let's see. This is the example. So actually, if you see that, as I told you, we will use a set and we will use a dictionary. In dictionary, we will map the character, or we will save the characters map to the another character. So here like P will be mapped to T. So we'll store it here. So now to like check if we have saved a character, will like when we are like adding it to the dictionary, we will add this value to the set. So that means that we have already visited. So this is basically a visited set. So we know that these characters are already used. So if we try to use this again, that means the string is not isomorphic. The strings are not isomorphic. So we will simply return false. So here, if we try to use this approach, there will be actually three conditions. First of all, the base condition will be, we will check if the size of the both strings are not equal. Well, if in this question it is given that size will be always equal. So if in other problem statements, if you know, if you are asked an interview, you should do tell this condition that if the size of the strings are not equal. So that means if the size are only not equal, then we won't be able to like convert this string into the another string, because we cannot add or remove any character. So we will simply have to convert this into this. So we'll have to replace this character by another character. So that is what we can do. So that means that if the size is not equal, so we will simply return false. So now as I told you, we will use a dictionary and we will use a visited set. So dictionary is actually a key value pair, and set is actually which contains all the numbers which are not duplicates. It will not contain duplicate numbers. So now what we will do is we will traverse over the string. So we will traverse over both the strings. So size will be from 0 to n. So it will be 0 to n minus 1 actually. The loop will run from 0 to n minus 1. And what we will do is, now when I is at this point, we will check our dictionary is empty. Okay, our dictionary is empty. We will check if this character is already in dictionary. So it is not in dictionary, and our set is also empty, and we will check if T is in a set or not. So it is not there. So now what we are doing is we'll simply add this P. So you should not look at this algorithm first of all. So I will explain you from here only. So you can see first we will our dictionary is empty. So we will add this P and T here. You can see this P is the key and this T is the value. So now when we are going to next step, before that we have to do is we have to add this also here. So we'll add T here. That means we have used T, or T is visited. So this is actually, you can say this is the visited set. So I've written S only. So it is actually visited. So now when we go to the next character, so I will come to this point. So now we will check if this character A is already in dictionary. this is not in dictionary, so nothing will happen. Okay, so, and we will check the another condition. You can see this is the if condition, so we'll check if that element is already in dictionary. That means it has been mapped to the another character, it has been mapped to the character which it should be replaced with. So in that condition we will check if the dictionary element, so that here you can see here it was P, here again if it was P, we will check if this P is already in dictionary. So yes, it is already in dictionary. We will check if this P of I is replaced with this or not. If P of I is in map, we will check D and S of I. So S of I is P, so DP that is T is equal to this character that we are on. This is I, so it is not equal to I, so that means it has been replaced by another character, and we are trying to map it to two different characters, so our condition will fail. So that means they will be not isomorphic, so we will simply return false from that point only. So now let's see the next condition. So now, as you know, here we don't have that condition, so it is like till this point it is true. So when we are on this, A is not in the dictionary and I is also not in the set, it is not visited, so we'll simply add it to our dictionary. So it will become A here and it will become I here. So now we will increment to the next index, so it is P. So now you can see P, we will check this condition, if condition. So S of I, that is P, is already in dictionary. That means we have mapped this character already. So now we will check this value. So basically in this condition what we are doing is we are comparing this value with the value stored in the dictionary. If this value that we are getting in the dictionary, P's this value T is not equal to the current value of the T of I, that means that we are trying to map two different characters to a same character. So that means we will simply return false from that point only. So this condition is doing this job. So now, as you know, if this condition will be actually false. You can see D of S of I, that is this T is not equal to T, this T, so it is false, so nothing will be returned from here. So now this will be iterated to the next iteration, so it will become I will be coming here. So these are like done. So now we will check if E is already in dictionary, so it is not there. P and A are there and E is not there. So here, as I told you, we will have to add. So I forgot, you can see here we have to add the set, the value in the set also when we are adding it to the dictionary. So here we have added I also. When we were at this point, we have added I. Okay, we have added I. So now when we are on this point, you can see E is not there. E is not there in the dictionary. So we will simply add E and we will add this L. We will map it to the L. So now we will increment. So these are, you can see, if and else, if and else. So if this will run, then these two will not run. If this will run, then these two will not run. So this is like that. So now when we come to this point R, so again if we check, R is already in dictionary. So no, it is not already in the dictionary. So we'll simply add R and add its value. So as I told you, we will update the set also. So set will have actually T, I and L after this point. So now we add R. So R and E are added in the dictionary, and you can see E will be also added in the set. So that means we have not encountered any condition which returned false. So that means at last we'll have to return true. So here one more condition will be written. Actually we will have to return true at the end of the function, because if the it has not written false, so that means they are isomorphic. So we have checked we have iterated over all the length of the string and it has not failed any condition. So that means we have to simply return true. So if we try to run this algorithm on this example, so let's see on this example also, it will be like easy one. So let's add this F to the dictionary because it is not already added. So F is added to the dictionary and we have our set. So our set will be updated. So this value B will be added to the set. It is B now here. So now when we come to the next iteration, so we see O. So O is not in the dictionary. So that means we will simply add. So this else condition will be run. So this will be added. So it will be O and it will be mapped to the A. So A character is mapped. So now when we come to next iteration, we check O. So O is already there in dictionary. So we are checking if S of I is in dictionary. So yes, S of I, that is O, is already in dictionary. So now what we have to do is we have to get the value of that O. Okay, so value is A here. You can see value is A, and we will compare this A value with T of I. That is the character that is corresponding in T of I. So it is R. So now you can see this A and R are not equal. So that means we are trying to replace O with two different characters, or we are trying to map it with A and R, that is two different characters. That means our condition will be false. So we will simply return false. So this is how our algorithm will run, and the time complexity for this algorithm will be actually O of n, because we are traversing O of n. Actually size will be same. So if we see this size will be n and this will be also actually n. So we will simply return n, or this time complexity will be n, and the space will be also n, because we are storing the values in the hash map and we are using a set also. So the space will be n. So now let's see the code. So I will also provide the code in the description. You can check it from there. So I have written the code in Python. So this condition is actually not required in this case, because here we are already given that the length will be equal. So if the length of the both strings are not equal, so we will simply return false if this is not given, this condition is not given. So now here I have initialized a dictionary and I have initialized a set to show the values, visited values. So you can see this is a visited set. So now we will traverse over this strings. So it will be for I in range n. We can run n because the size is the same as I told you. So we will run this loop and we'll check for three conditions. If the element that we are on, s of I, is already in dictionary, we will check if its value is equal to the t of I or not. If it is not equal, that means it is mapped to two different characters, so we will simply return false. And as if we will check if t is already in visited, so that means if we are trying to map, so as I told you in this condition actually, when we are writing this, so if like here it was E, G and L for example, and here is A, D and D add. So now when we are trying, we are adding this to set, okay, when we are running this, so when we are added this to set, so we'll add this again to the dictionary. So it will be added G and D are added in dictionary and L and A are added in dictionary, and this D is in our set. So when we come to this, so here the first condition will not run because it will check s of I is in D. So s of I is L, so it is not in the dictionary. Here we have egg, so it is egg, so you can see E and G are in dictionary but L is not in dictionary, so this condition will not run. So now when you check this condition as if t of I in visited, so now you can see t of I, that is D, is already in visited because we have mapped it to a different character. So we will simply return false because we are trying to map again two different characters to a single character. So that is why we will return simply false. This is for that condition. And else, that means both condition is true, so we will simply add it to the dictionary and we will add the value of that or t of I into our visited set. That means we have used it. And if this condition does not return false, so at last that means the strings are isomorphic, so we'll simply return true at the end. So let's submit this. So I hope you like this video, and guys, do subscribe this channel for more such videos, and I will also provide the code in the description. So you can see this code runs faster than 99.80% of the solutions, and it took less memory than 90.91% of the solutions. Thank you for watching.